I came across this question on Stack Overflow. Stateless services versus HTTP client wanting to be a singleton. Popular opinion seems to be that HTTP client should be used as a singleton. And then here, however, it is considered good practice to use stateless services, particularly, but not exclusively, when doing TDD or DDD. I did provide an answer to this question, so I will leave a link in the description. My first suggestion would be to always pass data into a domain and not have the domain call out through any service or any other mechanism to go and retrieve data. So in this case, even if you do have a service that does an HTTP client call, that service should not be used directly in the domain to make a call out. Instead, that call should be made in the application layer, and that data that is retrieved, if the data is required by a domain, that data should be passed into your domain. In this video, I'd like to deal with that scenario where you require a specific type of singleton, but it is not stateless. This means that you may require a specific instance of a singleton with the state that you need in your use case. I will be using the HTTP client as an example to see how we go about doing something like this, since the HTTP client is not stateless. To get going, let's create a new .NET Core class library. I'm also going to add a test project. Okay, so let's get going by creating a fixture for our HTTP client provider. At this point, this is very much an integration test since we are going to return an actual HTTP client instance. All right, let's see whether our provider sends back an HTTP client instance for us. Since we are returning a singleton, we should actually add another test to ensure that we are getting the same instance each time we make that call. Quite obviously, our test has failed since our provider is sending back a new instance each time that we call it. So this is where we're going to have to refactor this to send back a singleton. And since we know we're going to be working with a list of these things, we might as well go ahead and create a list of HTTP client instances. The question now becomes how we identify those individual instances. We could use something like an enumeration. However, each time we add a new HTTP client type, if you will, then we are going to have to update that enumeration, which is not ideal. So we'll go with a string identifier for now and see how that goes. Okay, so we'll run our test again and see whether it passes now. And our test has passed. We are returning the same instance for the same key. We can now extend our provider to return different instances based on the name that we ask for. However, we have to decide what to do when we ask for a name that does not exist. We can probably throw an exception, since asking for a name that doesn't exist and say returning the default would lead to unexpected behavior. So let's go ahead and implement the named instance get method. And we should also write a test for the scenario. And our test passes. The question now becomes, where do those new instances come from? Our provider could act as a bit of a registry where we can add the new instances directly to the provider, or the provider could use factories internally to create the new instances as they are required. You can even use callbacks, but that all comes down to preference. Let's implement the registry option first. And we want to also make sure that this method works using a test. That went okay, so let's see how we can use the factory pattern to get the same result. We can either create a single factory and pass in the name of the client that we want and expect the factory to determine how to create that specific client. Another option is to use a factory per named instance, which is what I will be implementing. We could add these factories to the provider using an add method, but I will be passing them in through a constructor. I'm going to register the default client in the constructor and then also make use of the factories when requesting a named instance. Now we can add a test to see whether we can make use of those factories. Two more ways that we can get to an HTTP client instance is by having a callback function that creates the HTTP instance and another that configures it. We also need to refactor the get method in order to make use of these callbacks. And of course we'll need the tests for those two methods as well. Now let's run our test and see whether that works. Next is the callback that just configures an HTTP client. Let's see the results of this test. If you're wondering what the difference is between those two callbacks, the function is expected to return an HTTP client instance in the same way that a factory does. The action, on the other hand, receives a client's instance already and simply configures it. One extra bit that I'd like to mention in a scenario specifically like this, where you have a concrete class like HTTP client, is that you might want to actually create your own subclass from that HTTP client that has an interface that you can use for mocking. Then I'd like to end off by just mentioning that in the original question, the original poster did mention that there is now an iHTTP client factory that manages HTTP client instances. So this is probably something that you would like to use in a situation like this. However, the concept stays sound, and if you do find yourself with multiple singletons that you need to manage, I hope that this video will provide you with some guidance and that you may find it helpful in actually dealing with these situations. Thanks for watching.